in the previous video, we actually derived the analog phase lead, okay? And in this video, we're going to talk about the digital phase lead. And the purpose of us doing the pre-warping in this case is that I believe, I don't know whether I told you in the past, I forget already, but anyway, is that for example, you have this certain transfer function, alright? And I write in terms of S, I write in terms of j omega, the analog frequency, okay? And 0.1 plus 1, okay? So this one is your analog system. If you were to do in terms of the digital system, you're going to sub in your S as either one of them, right? So in this case, I sub in as trapezoidal, okay? So instead of having S, I'll write as 2z minus 1, alright, t z plus 1. So this thing over here is your S, okay? And then plus 1, alright? And then multiply by 0.1 S. So S again, I sub in as this one, okay? That's all. So this is your S, this is your S, okay? And if you remember, your Z is equals to EST, or in other words, is also equals to EJ omega T, or your S is J omega. Okay, so in this case, we sub in as the digital frequency, your omega. Okay, I don't want to confuse you between the omega, this omega, and this omega. Alright, because this is the analog frequency, this is the digital frequency, but they are the same value because they are just simply input frequency. But I just want to tell you that this is analog input frequency, this is digital input frequency, but they are in fact the same. So if I input 3 over here, I will also input 3 over here, the frequency. But I just want to define clearly between them. Okay, so Z is equals to E. If I were to do that, what I will have is this thing. So I change my Z, or I change it to EJ omega T. Okay, then that's all it is. So you see, with the, for example, if the same transfer function, I can rewrite as an analog system, I can also rewrite as a digital system. Same transfer function, alright? And therefore now in the next part, if I were to input the same frequency, alright, if I were to input the same frequency within it into digital and the analog, so if for example, if I input 3, for example, this is also the question, what the question say, alright? So if you input the same frequency, alright, you should by right get the same results, alright? So my digital signal over here, if I were to solve for it, I should get back this value. But in fact, I will not get this value. Okay, I will not get this value. You can try it yourself, I will not try it. Alright, and therefore, there is clearly a problem because with the same transfer function and the same input frequency, alright, 3, you should get the same answer, but you didn't, right? So this is clearly the distortion effect due to this subbing in of the stuff that we have done in this digital part, alright, which is this one, okay. So therefore, normally we want to do a pre-warping, okay, and on a bilinear, because the bilinear is the most better one compared to forward and backward. So normally we will do the bilinear one, okay. So this is just an introduction to let you understand why do we use pre-warp. So at least you can understand that same transfer function and same frequency, alright, the digital and the analog is different, alright, and therefore in this case, let's continue on trying to prove to you that after the pre-warping, alright, we can in fact get this same result, alright. So without further ado, we just start off. Yeah. So over here, I'll just write as H, alright, the first step. I should say that the first step, omega 1. Okay, if it's just omega, you can just write as omega also lah. Okay, but anyway, so over here, Hs divided by omega is the first step. S for whatever S that is, you divide it by A. Okay, so for whatever that is not S, alright, you just divide by omega. In this case, it's omega 1, so you just write as omega 1, alright, divided by, for S in this case, we'll divide by A, okay, and then plus 1 over omega 1. So this is the first step, okay. If it happens that you need to understand something about pre-warping, alright, one question to pose to this is that why do I divide S by A only? Why don't I divide this one by omega? Why do I divide this one by A also? Okay, so this is a question in the future. It happen that you need this, more derivations than, yeah. But anyway, let's come back to here. Alright, so this is the first step, and the next step is that, alright, we need to solve for the A. Okay, solve. So your T now is given, alright, as 0.25. So I'll just sub in as 0.25 tangent omega is given, right? Omega is given as 3 table over here. Okay, so this 3 times your t is equal to 0.25. So I have that. Okay, and then if you have to evaluate this term, alright, in terms of radian, be careful of that, we're operating in terms of radian. What I have is 3.149, I mean 3.149, yeah, 3.149. Okay, and the next step, since we know that we have A, alright, we found that A is 3.149, okay, and that the omega 1 is equals to 3, I can simply substitute it into this formula already. Alright, so if I were to do that, what I will have is thing. Okay, so my A I change to 3.149, while the omega I change to 3. Same as for the denominator for all of them. Okay, so this is the I should say this is the third step. I don't know why I write 2. I bit check already now. But anyway, so the next step is the fourth step, right? So what I will write is think. Okay, so in fact I should also write this, alright, as S divided by A now. Okay, because I actually changed the A itself. I don't know, this is some terms that you may need to understand. I don't know why but this is small things are small fry. So at first you just rewrite as this thing. Alright, next I change, when I sub in A, I'll just rewrite as that. But you can also rewrite as omega 1, I don't know, I'll leave you to think about it. But from the paper itself, I see that over here they write as HS over A lah. Okay, but this is just some notation, no need to care about it. The key point is still the answer. So over here, this tells you that you need to sub in S is equals to this thing, which is your trapezoidal. Okay, so this is why over here we sub in our S over here as trapezoidal now. Okay, so what I would have is, okay, so this one over here is your S, and this one over here is your S. Okay, I didn't cheat your feeling, you see. So it's 0.1S is your over here, your 0.1S divided by 3.149. Alright, so just take a look lah. Okay, and in fact I've cheated your feeling, because this one over here I should have divided by, give me a while, should have divided by 3.149. You see, your S is this one, divided by 3.149. So this is something that you need to be careful of, alright? Careless mistake. If you forget to stop in, you die already. Okay? So this is something that you need to take note of. So the fifth step now is to sub in again. Okay? So you know that your Z is equals to EST. Alright, your Z over here, or all your Z's all over here are your equals to EST. Or in other words, EJ omega T, because our S is equals to J omega. So therefore, yeah. So T, you know, is 0.25. Your omega is equals to 3. Okay? So therefore, I'll just sub in all this thing into this thing. Okay, so you give me a while. Okay, so in order to prove that I'm not cheating your feeling, your T is your 0.25. Okay, and then your Z I sub in as E 0.75J. Alright, this is 0.75. Although from your screen I think it looks like 0.2, but it should be 0.75. Okay, if I have to zoom in, it should be 0.75. Okay, but anyway, so I sub in my Z as this thing. Z is equals to this thing, because it's J omega T. Your omega is 3 times your T is 0.25, so you have 0.75 J. Okay, so just simply sub in my Z, alright, and my T all over here, you see. So I didn't cheat your feeling lah, you see. So all this stuff I actually brewed it up there. Okay, and next step, alright. And in fact now what we're doing is actually doing math already. Alright, the only key step from your starting part is for your S over for your transfer function. Alright, for transfer function over here, your S you divide by A. Alright, your whatever thing that is not S you divide by the frequency that they want you to warp. So normally they'll tell you what is the warping frequency. Alright, so if it's omega 1 is a warping frequency, then you use the warping frequency. So it depends on what type of frequency that they want you to do. So you divide by whatever thing. So whatever that is not S, you divide it by the warping frequency. Whatever that is S, you divide it by your A, where your A is this one. Okay, just want to recap to you before we carry on now. Okay, and just to inform, we are still quite a bit way to go. So let's continue now. Now to brighten up your feeling, I'll write 6. Okay, in pink. Anyway, so this portion over here, you take a look, is some constant value. This thing over here, you take a look, is some constant value. So I'll just evaluate these constant values, and including this thing also. So I'll write in terms of a number. Alright, so later on you get to see why I'm doing that. I'm trying to clear things up a little bit. Alright, so I'm trying to rearrange stuff. As being written over here, rearrange stuffs. Okay, so if I were to rearrange all this, for example, if you don't know how to evaluate this type of functions, alright, you can write as 2 divided by 0.25, alright, divided by 3.149. Okay, so this, what I've written is for this thing. Okay, and then you can rewrite as 0.25 times 1 over 3.149, and then you can evaluate this term. Okay, so if I were to do for all everything, alright, so what I will have is, hey, so isn't it neater now? So I've reorganized all this portion, the one that I've circled in pink now, in all this now, you see? So it's slightly neater now, alright, while all your stuff over here I didn't change lah, it's still retained, as you can see from the color. Alright, so what I'm gonna do now, alright, is I'm gonna rearrange this thing again, alright, because there is still a denominator over here, right? So I'm trying to remove the denominator. So what I would suggest is that we can multiply everything by this thing. Alright, so you multiply everything by the denominator. So this whole thing is still equals to 1. Okay, I didn't change the whole transfer function. I only rearrange it in terms of trying to multiply something with it. Okay, so if I were to do this thing, alright, what I would have is that, give me a while. So this thing over here, if I were to multiply with this thing, so this thing over here will multiply, will cancel each other. Alright, and this thing over here will multiply with this thing. Okay, so what I will have is, looks like this. Okay, okay, I simply multiply it into both of them. Okay, so 0.3, I mean 0. What I mean talking Chinese, but 0.33 times this one, you have this one. Alright, while this thing over here, alright, this thing over here, if you multiply it, you cancel each other. So what you have is this thing. Okay, and therefore next thing is that multiply the denominator, same thing over here. Okay, I think you guys mean already, right? So therefore what I would have is, so I have the denominator being spawned out over here. Okay, so same thing, alright, for the denominator, as I say, I multiply both of them. Okay, I multiply in so you can just take a look lah. You can just compare this thing to this thing. Alright, okay, and so next one we're gonna do is to rearrange this thing again. Alright, I'm gonna multiply into both of them. Okay, so I'm just trying to make things in a way that is easier for us to evaluate. Okay, so if I were to do this now, okay, I'll have this thing. Alright, so this portion over here, think about it, is actually this one. I multiply this thing over here, as you can see, 255 and minus 255. Plus 255 times minus 1 is minus 255 lah. Alright, and then as for this thing over here is this portion over here lah. You just compare. Okay, same thing for this one is this one. Alright, this thing over here is this one. Okay, so you can see quite clearly now. Okay, and therefore as you can see, next we'll just sum all the real numbers and all the exponential as a term, as the same term lah. Okay, so if I just merge them together, so 2.55 plus this thing, I will have something lah. Okay, and rearrange stuff, minus 2.5 plus this one, I think you get what I mean. So I'll just simply rearrange now. Okay, so what I will have is, okay, so as you can see, this is way neater now. Alright, so we've gone through all these processes, the rearranging part. Alright, we actually do quite a lot of stuff in order to reach this, and we haven't finished yet. Okay, so I'm gonna take this answer, alright, that we have just found. Alright, I'm gonna write in the next step. Alright, so this is the 7th step. So the next step is apply the Eulers formula, where your ej theta is equals to cosine theta. Alright, e minus j theta is something like this. But in our case, we only use ej theta, you see. So this is something like ej theta. So if you don't find it familiar, I can just shift this over here. So your theta is your your 0.75. Okay, so your theta is this one over here. Okay, and next is that I just sub in so I just rearrange, I'll just sub in my Eulers formula as all this thing. Okay, in terms of 0.75. So what I would have is this thing. Okay, so I sub in this one as this one. Okay, so I rearrange this one as this one. So your theta, as you can see, if you're not familiar or you forgot, is our theta g is equals to cosine theta all over here. Alright, so in this case it's 0.75, so this is why I put it as cosine 0.75 and sine 0.75. Okay, something that you need to pretty much understand. But anyway, so currently now we just simply evaluate these numbers. Okay, what I would have is, so if I evaluate this, all this cosine and sine, alright, in terms of radian, alright, right, in terms of radian, not degree, you have all this value. Okay, I just want to explicitly define to you all this value, so at least when you're doing, you can check. So next, I'll just multiply it in and then rearrange in terms of the real numbers. Anyway, I'll just multiply step by step now. Okay, so what I will have is, okay, so what I will have is all this, forget the divide. Okay, so this thing I multiply in, I'll have this one. This thing I multiply in, I'll have this one. Okay, and minus 2.2, I leave it over here. Okay, and then this portion I multiply in, and I'll have all this. This one I keep over here. Okay, so next I'll evaluate 2.1 minus 2.22 because they are real numbers. These are all imaginary numbers. Okay, so I will just rearrange the real numbers. So what I will have is this thing. Okay, so I'll just evaluate the real numbers. I'll just add them all together. Okay, so this is the outcome that I have lah. Next is that if you remember, our objective is to find the phase late. Alright, so we are almost there already. I don't know whether I'm correct because it's the first time I'm doing this. Okay, so what I would have is that if you remember, the angle is tangent inverse the imaginary over the real. Okay, so divided by the, okay, so this portion over here for the zeros, which is all this, is the real, imaginary divided by the real. Alright, imaginary divided by the real. Okay, while the poles over here I'll evaluate in terms of this also, in terms of radian. Okay, so in order to find phase angle, if you still remember in the previous video, we take the zeros minus the pole. Alright, this is what we're doing, the zero minus the pole in terms of the angles, or the degree, or the radians. Alright, so if I were to evaluate this values, so if I were to just write it down, sub it in first in case you don't know what the hell I'm talking. Okay, I just sub it in only. Okay, while the real numbers I sub in as this one. Alright, same thing for the poles, you'll just sub in what I've just done also lah. Okay, if I were to evaluate these numbers now, the result is, to evaluate you have minus 2.179. Alright, I should explicitly define as a radian. Okay, and now if I were to solve for this thing, I would have divided by pi times 180. So I'll change it to a degree form. I would have is a negative 124.84. If you were to show it in a graph, alright, this is negative, alright, 124.84. Okay, so if I were to draw all the way down, this should be at the origin. Okay, sorry, I didn't have for that. Okay, so this is negative 124.84 going in this direction. So if you were to look at this thing over here, what do you have? So I'll just add plus 180 degrees. Okay, so what I would have is, I would have 55.15 degrees. Okay, so this thing over here is my 55.15. Okay, so if you were to compare this to our analog, what we have calculated is 54.95. Alright, the difference aren't that big, and in a certain extent. Alright, as you can see, 55.15 and 54.95 is somewhat a bit about 0.2 difference, but at least you get to see that it's pretty good still. Alright, it's still pretty good, pretty nice. Alright, and therefore this is the method of doing the pre-warp. And nonetheless, I may be having certain careless mistakes somewhere, because by right we should get 54.9, but yeah. But anyway, this is the general steps of doing things. So just a quick review back. Alright, the first step first, you whatever s in the transfer function, this is your transfer function. Whatever s, you change it to divided by a. Whatever thing that is not s, you divide it by the warping frequency that you want, the omega 1. Okay, and then you solve for a using this formula. You need to memorize this formula. Okay, and then next you just sub in your a and your omega, alright, as the values that they want. Alright, and then next I sub in my s as my trapezoidal. Alright, so normally the pre-warp is only applicable for trapezoidal, so you just put in the trapezoidal. It's just simply doing the things that they want. It's just subbing in only. Okay, so what you do this already, next you sub in your z as est as ej omega, as ej omega t. So you sub in your z as ej omega t, and then your t and your omega wherever omega 1. Alright, just sub in all over in your this section over here lah, based on these definitions as we have said. Okay, and then after which we do a huge rearrangement until here, and the key step of the rearrangement is to multiply by the denominator. Alright, so this equals to 1, right? So you rearrange in terms of the denominator, so you eventually get this value, and then once you get this value, you apply the Eulers formula, right? Ej theta is equals to cosine theta plus j sine theta, alright, for this case. So you will have all these things, and then evaluate, you get this thing over here, and then the next critical step is to find your radiant, alright, and then eventually you'll get the thing that we want. Alright, so yeah, I'll leave with this now.